All right, this is intermediate algebra. We're in section A, not 8, A, point 2. This is the second video, or part B, and it starts on page 9 of your book. The topic is compound inequalities, or working with the OR statements. Example 6 on page 9 says solve 7x minus 5 is less than or equal to 6, or x plus 7 is less than or equal to 5. So the first thing we're going to talk about is OR. The last examples we did were all and just means that the solutions for x, the numbers that qualify to be x, meet both qualifications or both statements at the same time. It's the overlap when you graph. The OR statement is different. OR is not about overlap. OR means that x can satisfy this equation, or it can satisfy this equation. So in mathematical terms, this is a union where and is an intersection. And is about overlap, or is about everything. It's a union. All numbers that meet this qualification are part of the solution, and as well as all numbers that meet this qualification. So OR is different from and. The first steps are the same. We're going to isolate x. So we will add 5. So we have 7x less than or equal to 11, and then divide by 7, and we have this lovely fraction 11 over 7. X is less than or equal to 11 over 7. And we'll do the same thing with this statement over here. We'll subtract 7, and we'll have x is greater than or equal to negative 2. And we have our OR in the middle. So this is our solution statement. We can graph OR all on one graph. We don't need two because we're not looking for overlap. The first thing we're going to do, we know there's a negative 2 on here, but where is 11 over 7? If I change this 11 over 7 to a mixed number, it's 1 and 4/7, so that's between 1 and 2. So I will put 1 and 2 on there, and my 11/7 is going to be someplace right in here, and I'll mark that as 11/7. So when we graph this, x is less than or equal to 11/7, so this will be closed at 11/7, and I will be shading less than everything that's less than 11/7. Okay, because this is an OR, not an AND. X is greater than or equal to negative 2. Alright, I'm terribly sorry, but I'm seeing that I made a mistake when I wrote this question, and I really do want it to follow along with your book. So we're going to make some changes back here. This should not be a 7. This should be a 2. I just read it wrong. I don't know if I can erase it. Yes, I can. So that's going to change all of this. This should be x plus 2 greater than or equal to 5. So we will subtract 2 here. And that means that this is 3, not negative 2 or whatever I have there. Okay, so back to our graph. This part is the same. Less than or equal to 11 over 7. This is greater than or equal to 3. So I have a 3 here. It's closed. X is greater than that. If this was an AND, we would be looking for overlap. There wouldn't be any overlap. This is not AND. This is OR. That means all of this is the solution. All of this is the solution. OR means a union. Everything that meets this qualification is part of the solution, as well as everything that meets this qualification is also part of the solution. Now this can be a little tricky to write in set builder or interval notation. Let's use green for set builder. You've got x such that, and the only thing you're going to do is you're going to use this statement with the OR. So x is less than or equal to 11 over 7, or x is greater than or equal to 3. If when you graph an OR, if your shadings don't touch, like in this case, you have to use the word OR in your set builder notation. You can't use a comma because comma means and. you have to use the word or. Now for interval notation, if your shadings don't touch, then you have to write an interval for each piece of shading, and you will join them with a U for union. So for interval notation, we have negative infinity to 11/7, and we have brackets, and that designates this piece of shading, starting at negative infinity going to 11/7 with brackets here because the equal bar made this closed. By the way, we use improper fractions in interval notation, not mixed numbers and not decimals. Improper fraction. Then we will write an interval for 3 to infinity, and that's this piece of shading right here, closed at 3 because of this equal bar, so the brackets here all the way out to positive infinity, and then we join them with the U for union. That means that both of these sets have part of the solution, or have numbers that meet this solution. Okay, example 7 on page 10 says x minus 7 is less than negative 5, or negative x minus 1 is less than 0, and again with the or. So we're going to first isolate x. That's your first job. So we have x is less than 2. We have or. We'll add 1 here. And we again have this, when we have this negative sign on our x, we have to get rid of it. We're going to divide by negative 1. When you divide by a negative, it flips the direction of the inequality symbol. So dividing by this negative 1, change this less than into a greater than. And now I have my solution set as x is less than 2, or x is greater than negative 1. I'm going to graph this all on one graph. I'll put 0 here, 2 here, negative 1 here. All right, this says x is less than 2. So all of these numbers less than 2, all these numbers less than 2 are part of the solution. This piece says x is greater than negative 1. So every number greater than, now this is not going to stop. It's not going to stop here at the 2. All numbers greater than negative 1 are part of the solution. So this goes out into infinity also. If this was an and, we would only be looking at the overlap here in the middle. But since it's an or, everything that is less than 2, even these over here, and everything greater than negative 1, even these over here, that's what the or does. It's different from and. Or means everything that meets those qualifications. So it looks like my entire graph is shaded here. So that if that's the case, then the solution set is all real numbers. In a set builder notation, x, such that x equals all real numbers. Your book writes this as x is less than 2 or x is greater than negative 1. I think this is kind of ridiculous. This doesn't really tell that you really mean anything, you really understand anything. This one up here, x equals all real numbers, really shows that you understand. The entire graph is shaded. For interval notation, of course, all real numbers is negative infinity to positive infinity. Whoops. And infinity always gets parentheses. All right, that's it for this section. Make sure you work on the homework. Bring your questions back to class. I'll see you there.